Okay, welcome back, dear students, and here we are going to talk about the last part of our chapter sets. The idea here is the complement of a set. Let's notice this example. If the set A includes the elements A, B, E, and D, and this set A is a subset of the mother set E, or sometimes we call it the universal set E, that includes A, B, C, D, E, F, and G. So notice that A is a subset of E. Then the complement of A in E, which we usually call or represented by A bar, is the set including the elements C, F, and G. So what do you notice? Let's think a little bit. We notice that these elements are not found in A, so they are the missing elements in A, but definitely they are found in E. So what's the definition of the complement of a set? The complement of a set A in E is represented by A bar. It includes the elements of E that are not in A. So as you see here, the elements that are not in A are C, F, and G. We collect them in a set. We call it the complement of A in E. We represent it by A bar. Here is a note that says, that's a logical note, that A intersection its complement A bar is definitely phi, sure, because these two sets will never have common elements. While A union A bar, A union its complement will definitely give the mother set. As you see here, if you take the elements of A with the elements of A bar, then you're going to get the set E. A note that says, if the set A is not a subset of the mother set E, for example, if there is an element I here, then definitely A is not going to be a subset of E. Then we cannot talk about A bar, which is its complement in E. So if the set is not a subset of the mother set, then we don't have to find, or we cannot talk about its complement in this set. Here is an example to make things clearer and to notice new things. Consider this set E that includes 1, 2, 3, 4, 5 till 9 and the following subsets. Because there's the word subsets mentioned here, then definitely A, B, and C are subsets of E, and E is considered as a mother set for A, B, and C. So if we have to find A bar, which is the complement of A and E, all what we have to do is to search for the missing elements that are not found in A but they are in E. So what are the elements in E and not in A? They are 2, 3, 5, 6, and 8, and this is what we call the complement of A, which is A bar. Similarly for B bar, the elements of B are these, and the elements of B bar are just the elements that are in E and not in B. They are 1, 5, 6, and 9. We collect them in a set called B bar, which means the complement of B and E. Similarly, for if I have to find A bar intersection B bar, so all what I have to do is to look at this set and this set and to search for the common elements in them. 5 here and here, 6 here and here. So A bar intersection B bar, A bar, as if I'm reading it, A bar intersection B bar means I have to find the intersection between A bar and B bar. Let's continue to discover more ideas. Now, if I have to find A bar union B bar again, I have to look at this set and this set and to collect the elements of both. 2, 3, 5, 6, 8, 1, and 9. Notice we don't repeat the common elements 5 and 6 twice. So this is the collection of elements of A bar and B bar together. By this we find A bar union B bar. Now if I'm asked to find A intersection B, then I'm going to go back to the given sets A and B. What's the intersection between A and B? The common elements are 4 and 7. So it is just including 2 elements, and as well we call it a per set as well. Let's continue. Now A intersection B bar. Listen carefully how I'm reading it. A intersection B bar. Then I'm going to find A intersection B, then the complement of it. While here it was A bar intersection B bar. The intersection of the complements. Here it is the complement of the intersection. So A intersection B bar. So first of all I have to find A intersection B, and it's found here. Then I have to make the complement for this set. What's the complement for A intersection B, which is just including 4 and 7? Surely I have to search for the missing elements that are 1, 2, 3, 5, 6, 8, and 9, exactly as you see here. Similarly, for if I have to find A union B and then A union B bar, A union B, as we said before, it's the union between the elements of these two sets, which are 1, 4, 7, 9, 2, 3. We don't repeat 4 and 7 and 8. So it is the set including 1, 2, 3, 4, 7, 8, and 9. While A union B, all of it bar, I'm reading it A union B then bar. So I have to find the complement of A union B. The only missing members or elements are 5 and 6. So A union B bar is the complement of the union. Now let's notice something concerning this. If you notice A bar intersection B bar and A union B bar, you notice that they are equal. So we have to discover a property that says that A union B, all of it bar, is equal to A bar intersection B bar, and we can use it as well. Also, if we notice A bar union B bar and A intersection B bar, we notice that they are also equal. So A intersection B, all of it bar, is equal to A bar union B bar, and this is a rule that can be used also. Let's continue this example. C bar. If I have to find the complement of C, so the missing elements are 2, 5, and 6 only. And finally, we have to discover a remark that says, notice that A is a subset of C. Notice that the elements of A are included in C, and A is a smaller set that's subset in C. So by logic, because the missing elements of A are more than the missing elements of C, we'll conclude that C bar is subset to A bar. So if A is subset to C, if A is a smaller set, it's a subset of C, then by logic, C bar is going to be a subset of A bar, and here is the proof here. This is C bar and this is A bar. Notice that C bar is a subset of A bar, where A is a subset of C. Now to sum up, here are important remarks. As we said before, that A union B, all of it bar, is equal to A bar intersection B bar. A intersection B bar is equal to A bar union B bar. Now logically, A bar bar, which is the complement of the complement, is the set itself. It's logic, it's obvious. Here are two remarks that you're going to see somewhere in exercises. A intersection B union C, as if you are expanding. So it's A intersection B union A intersection C. Similarly for this one, A union B intersection C, it's A union B intersection A union C.